Okay, let's try this again. I was trying to rush through that before, and that was a bad idea. So we've got this products produced by an industrial process. 11% in the past few months have failed, and they would like to improve that. So they've done something to modify the process to reduce the rate of nonconformities. So a random sample, 300 items, trial run, modified process produces 16 nonconforming items. And the question is, do these results provide convincing evidence that the modification is effective? Well, we're going to do a significance test for a proportion. So, the population proportion, the 11%, I guess right now is what the population is. So that's the P equals 11. We would like to see if what we did changes that to less than 11% or 0.11. The conditions. Do we have the random condition? Well, let's see here. Random sample 300. Looks like that's good. 10%. 300 times 10 is 3,000. And I guess we're going to assume that it's more than 3,000 for the population. N times P. Remember, N is 300. P is the 0.11. So 300 times 0.11 is like 33 if you round it. I guess even if you don't round it. And NQ is the 0.89, which is 260. Both of those are greater than or equal to 10. So, looks like everything works here. It is a simple random sample and such. So, what is P cap? Well, that's the 16 divided by 300, which is like 1.0533. Alpha, we get to choose, and many times 0.05, 95% is what people choose. 0.05, 0.10, 0.01 are the three popular ones. They'll have to give you that in the problem usually. Test statistic. It's P cap minus P over the square root of PQ then 1 minus P over N, 300. Okay. Now, this number, 1.0533, is incorrect. Gosh, I wish I'd have. It can't be 1 because 16 certainly isn't greater than 300. 0.0533. So it looks like it's better than 0.11. Is it good enough? Is the question. Our test statistic negative 3.14. The p-value is that area to the left of negative 3.14. And we get 0.0008. Now, how do you find that? You can use the standard normal curve, the area under the curve from a negative infinity up to a negative 3.14. You can go into the table and look it up, the area under the curve. So, since the p-value is small, that means we reject the null hypothesis. It's smaller than alpha, the 0.05. And that means there is convincing evidence for the alternative. It's too far away from this 0.11. Now, in this case, that's good. So sometimes rejecting the null hypothesis being for the alternative is good. So the true proportion of non-conforming items is less than 0.11. That's what you wanted. The p-value of your test, 0.0008, means, remember, that's the area to the left of negative 3.13. It is so small you can't see it on this picture. If you use the 1-prop-z test on your calculator, and I guess since we're not going to be tested over this, we won't worry about learning that. but you can get this number pretty quickly. This p-value, 8 times 10 to the negative 4. So now you can do a population proportion. You can check for random 10% large counts, that's NP and NQ. Perform a significance test and interpret the power of a test. Maybe not great because we really went through that quick. And this type 1 error and type 2 error, the power of a test. You get to choose type 1 error alpha because of the size of the population, and the type of 1 error alpha that really determines the type 2 error. It also depends upon what you choose for your new population parameter.